Hey everybody, my name is Brent Salisbury. This is Madhu Venugopal.
I guess.
We're both from Red Hat. We both work on the OVSDB project. Madhu's been working on the controller for a couple years now. There's very few people out there that know the controller like he does, so we're lucky to have him in the tutorial. So we've got a couple options on this. So we're digging into some complex things. So I know we've probably got a pretty wide range of skills on people that have touched things like OpenStack. So we're probably going to do some polling in the audience. So we're going to kind of start off with a pretty basic Mininet kind of tutorial. We're going to pass out VM images, so you'll get a USB stick. We should have enough. So folks that are more accustomed to using VirtualBox or VM Fusion or whatever you use for your desktop hypervisor, or if you don't even have it installed and you just kind of want to watch, we're going to demo it all up here as we go. So you're welcome to follow along. You know, it's complex stuff, just so we're stacking with OpenStack. Some of those things take a few dependencies. The images that we're handing out are all functional. So, and we're also going to put up the slides and stuff.
Just one thing, the USB sticks we need back. So because they're sharing the same USB sticks for multiple sessions, so please give it back and then before you leave. And those of you guys who were there in the previous session, you don't need it because you already copied the images, right? So please be honest, let us know so that the sticks are saved.
Let's hope they're in here. We haven't opened these yet.
So what do you want to do, buddy? You want to start with a simple one? Or?
Yeah.
So, a quick show of hands. I mean, we have two options here. I just ran a simple OVSDB OpenFlow demo in the next session. It's pretty simple to follow, you know, and we have an OVSDB Neutron OpenStack integration. So we have two kind of demos. One is complicated, one is kind of simple to follow and go along. Just show of hands, right? You guys want to just go to hit the nail with Neutron integration, or you want to go with slowly, see the demo of the basic one, and then go to the Neutron ones. So, basic one. Who wants to see the basic one again? Or there's few, so it's tough to decide.
What about OpenStack?
Yeah.
We got brave souls in here.
So no, Brent. No, let's start with OpenStack. Yeah, sorry. I mean, the previous session is already recorded, so you guys can see it later. Right. So.
And the goal is anybody that wants to kind of walk away with an OpenStack instance running, so if you'll start, anybody wants to follow along and you don't have the image yet, go ahead and copy down the image. Right.
Yes, stack. This stick has stack and basic pictorial stuff. So, but same. Oh, same one. Perfect. I'm going to give back, right?
How many people are using VirtualBox for a hypervisor? All right. How many people are using VM Fusion? Sorry. Sorry, VM Fusion. I know. Sorry, VMware. Maybe next time. So I'm going to give everybody just a second here to get the images copied down. So while that's getting passed out, the main thing we've had OpenStack integration with OpenFlow 1.0 for the past, I think probably we got done with that about 6 weeks ago. So there's a limitation with OpenFlow 1.0 that's pretty significant, and what that is single table. So if you look at an OpenFlow match in action, you just have one table. So that's an ordered list off of priority. Most everybody probably knows that. The problem with it is you have one table, you're going to match, and now you're out of the pipeline. So when you're dealing with tunnels and when you're dealing with anything advanced, any kind of service, multi-table is going to become really important. I'm going to pull up a slide here really quick that shows what the exact architecture looks like of what we're actually doing here. Sorry, I'm looking for the slide. Jesus. Yeah, here, 2 seconds. I can't find the, I should have had that up. Damn it. Looking for the slide.
The one,
I wanted to show just an overview of what we're
yeah,
stacking.
the one I sent you, right?
Oh, yeah, here it is. Never mind. Just a generic, and then I'll jump to that really quick. Oh, crap. Why is it not sharing?
Do a play if you want.
Oh, yeah, I'll jump into it. All right, sorry about that. So this is just kind of a generic overview of what the OpenStack implementation looks like. So we're using purely vSwitches. So this is an overlay deployment. We're using Open vSwitch on the edge of the network. We're using OpenFlow 1.3 in this. So we literally got done with this probably about on a 48-hour no sleep session about 2 days ago. So we're pretty spent, but it works. So, OpenStack is kind of the hello world for OpenFlow controllers or SDN controllers. So we needed to make sure we had that done. So what we'll do is basically you'll have 2 hypervisors. You're going to build an overlay tunnel between the 2. You can use GRE, you can use VXLAN encapsulations. So those are just basically simple tags. It's all stateless. And there's pros and cons to all this. So this is something that's easy to do for software developers right now. There's no constraints. We just need x86 on the edge. So with that, let's go ahead and get started. So I'm doing, hang on a second. Share out desktop. Screen. All right. I should. Yeah, that's we have some interesting times at night, in the middle of the night when we're doing this stuff. Oh my God, where is the? Hey, do you know where the screen is to get it up off the application and just do my desktop?
Do a display this one, right?
Yeah, I just can't find the stupid thing.
Display is
Thank
mirror.
you.
Mirror. It's arrangement mirror. Mirror.
Thank you.
Yeah.
Beautiful.
Watch.
All right. Okay. So first thing we're going to do is import appliance. So we're just going to import the virtual appliance that we had. So find the image you downloaded. It should be OpenDaylight DevStack Fedora 20. So this is on Fedora 20, obviously. Click Continue. Probably the only thing of note I've noticed on VirtualBox, uncheck this USB controller, and then click Import. Give it a second here. Yeah, I mean.
Once you have 3 or 4 nodes, right? 4 GB is not enough. Your stack is really, especially on the controller mode, at least have 4 GB.
So I'm going to click Start. If you're using VirtualBox, you are going to get an error here. So just click Change Network Settings, and then click OK. And we'll start spinning that up. So what I'm going to do is just set up the controller node right now. Then we're going to come back and set up another node that'll be the compute node. And when I say controller, it can get a little confusing. So there's an OpenStack controller and there's an OpenDaylight controller. there's an OpenStack compute node. So we're going to have 2 hypervisors total. So next, log into with ODL. ODL, it's very, very strict. We're pretty creative there.
And all this has been slides, so if those who are not following it up hands-on,
Yeah.
slides are all there. You just go home and start.
Come up here. Come on. Come on. Dude, you're the MVP, man. Come on. Get up here. This is the MVP.
No, all right, good.
Come on. Come on. Come on. Come on. No choice. So when you get in the home directory, you're going to have a local conf compute and a local conf control. Obviously, one's going to be for OpenStack controller and one's going to be for OpenStack compute. If nobody's ever used DevStack, what this is just an installer. Sorry, I probably should have prefaced it with that. That's what everybody uses in the OpenStack development side. It's going to pre-populate all the dependencies theoretically, and it's going to take about a week to get all the dependencies worked through. We're actually going to really start working on that. That's something that we're really interested in, is making a lot of this significantly easier to consume, because right now it's not easy to consume. A lot of that hinges on networks and images. So you're going to have an ODL directory and you're going to have a DevStack directory. So first we're going to go into the copy local.conf controller into the DevStack directory. So just cp localconf control DevStack. CD into the DevStack directory. You're going to have files there. Edit local.conf. Oh, there's already local conf there. Yeah, I'm actually going to.
Just do a copy.
Yeah, I'm just going to overwrite that. So I'm just going to do a move localconf.control and overwrite localconf, or you can copy it either way. So now let's edit local.conf. So what this has is all the stack settings. So you're going to have IP addresses and all the services that dependencies that run for OpenStack. So those are all there. I promise we've got this tested and run and all that kind of stuff. But if it breaks, that's just OpenStack and SDN. I forgot to get our local IP. Sorry. We need to know what our local IP is. So I'm going to come out of that real quick and run ifconfig. Let's run it on ETH0 first. You should have an IP there. If you're using VirtualBox, it should be 10.0 to 15.
Leave it in that.
So and the image forces, I think and then you should have an IP address for out of band. So if you want to telnet, or I'm sorry, SSH to this, see, that's my networking background coming in. Who uses telnet? Oh, networking. Sorry. So I'm actually going to SSH into it. Yeah, I'm going to make it bigger. Sorry, I've got this miniature window up here. So we're going to SSH to that 192 address. So if you're on VM Fusion, you can just SSH in. It builds in to any of the addresses. It builds in a patch port. But for this, 192.168. So SSH, ODL at 192.168. 58.101. Oh, was it 56? Sorry. Mm-hmm. Yay. Oh, hang on a second. 2, 15. Oh, hang on. That might help. Sorry. Sorry, I had another machine running with the same address doing this. There we go. So once you SSH in, ODL, go back into the DevStack directory. Get your ifconfig that you're going to plug in via localconf. So on host IP, we're going to, since the host IP is ourself, we're going to put in, so the host IP is actually, so if you're a compute host and you're attaching to a controller, that compute host is where you plug in host IP. If you're a controller and you're stacking it on the controller, well, you're the host IP, so you use the same address. 0.2.15. Did I pass? Yeah, I'm not even gonna. Where's the stupid service? Oh, crap. Oh, I was on it. Yeah, Roger. Why don't you talk while I'm doing this? While I'm typing. Oh, it's 101. And then VNC proxy address also changed. And so there's a big tag there that says if you just want to grep or anything on IP address of OpenStack control or compute. Bless you.
The reason it is complicated here is because once you have the VM copied, all the IP addresses is going to be screwed. Each one is going to have different IP addresses. So we do not assume any static IP here.
I'm putting in the wrong address.
So that's why it's a laborious process, but
I put in the wrong address there.
it's mandatory though.
2.15. That's right? On the VNC proxy, that's what I thought. It's all the same, 10.0. So yeah, I put in the wrong address there for a second, sorry. And there's one more at the bottom that you plug in that'll say IP address of OpenStack control. We're going to plug in.
What's the idea of the control?
10.0.2.15. I put in 192 at first, sorry. Sorry about that. Yeah, so we're going to run the controller, the OpenStack controller and OpenStack control, and the ODL controller are both on 10.0. We're going to bind to 10.0.2.15. Yes, sir. Thanks.
So see, it depends on your setup again, right? On this VM, he has this NAT interface as the primary one.
Right.
So in your setup, you can have host-only IP addresses, right? And choose one VM as your control VM, and have both ODL controller and OpenStack controller running on the same machine.
We're just trying to follow this.
Sure.
I was wondering which one.
Yeah, no, thanks for asking. If you have questions, everybody else is going to. So is that, any questions on that part? Okay, we're going to save it.
If you can go back to that.
Oh, yeah.
Just highlight.
Please.
So if you guys look at the final section, go down.
Oh, yeah, thanks.
So that is the latest OpenDaylight ML2 plugin that Kyle has implemented in the OpenStack. It's getting pushed upstream, but this is the code that is running locally on the VMs that you have on the laptop here. So you get the not so upstream yet code, it's hottest code right there. So that is going to talk to the OpenDaylight controller via Open APIs and do the magic for us. So it is the ML2 plugin for OpenDaylight.
And that's available on GitHub right now. So if you just go to the wiki, you can pull that and clone it. Everything else is going to be default, so we'll drop out of that. Another thing of note is while it won't break it, it will screw up some of the OpenStack naming. So, sorry, it didn't break very well there, but we do have, do need to change that actually. I don't know where he came up with that. So we're going to edit the host file so this matches up. Actually, we don't know the address of the compute yet. But when we do know the address of the compute, we're going to go into here and change this so that it resolves. And that's just an Etsy hosts. Okay. Next, we'll go into the ODL directory. So from the home directory of ODL, go into ODL. So this package here is 010. So this is the release.
This is the virtualization edition of the OpenDaylight controller. So the virtualization has multiple SKUs. We have VTN, we have OVSDB, and OpenDAO. Since this is an OVSDB demonstration, we want to run it as the OVSDB edition SKU.
And so one other small gotcha that we've got here is we've got the 1.0 script running by default here, and let's change that to 1.3. So I'm just going to comment out that pound. I'm going to add a pound so that it's going to start. So by default, the controller starts with 1.0. We want it to start with 1.3. Yeah. Then the other thing, there's one other file we're going to look at. It's in the configuration directory. Let me give the full path here just in case anybody's lost where we are. We're in Home, ODL, ODL, OpenDaylight. So let's go into the configuration directory. Let's edit the config INI. We're going to go down to, so these are just default values at runtime. And we're going to look for, so port being bound 6640, whoops. And notice here, uncommented is OpenFlow 1.3, or sorry, is OF.version equals 1.3. Right now, we're passing an argument of 1.3, and we've got it hard-coded in here, and the config file is 1.3. That's just, that's going to be addressed. That's, no, so you can totally run it as 1.0. If you run it as 1.0, the only difference is you're going to have a tunnel per tenant. So if you had 2 hypervisors and you're running with 1.0, you're going to have 2 tunnels for each tenant. So in order to have a key that's unique to that tenant or the network or a hash of both, you're going to have a tunnel for it. Where with 1.3, we can set, with 1.3 it's kind of interesting. You can set the tunnel ID using the flow mod. So using OpenFlow in the set fields in, what is it, 1.1 plus, we're passing and saying, okay, we want this flow to have this tunnel ID. What we use OVSDB for is saying this is the tunnel destination. So there isn't this IPv4 tunnel destination. That's a Nasir extension that uses a code point out of that that's referenced in the 1.3 spec. The only protocols, so probably the most interesting thing about this implementation is it's using purely native protocols. There's no agents and no extensions. So it's pure OpenFlow 1.3 and it's pure OVSDB.
Now, of course, OF13 scales better, right? Because we have just one tunnel between 2 into hosts. It can carry all the tenants you want, right? So that scales.
So let's go back up one directory. Oops. Look at one last time. Let's just make sure we're running the right script. We've got OF13. So this can all be passed in an argument. We made it easier by putting a wrapper on it. So you just do /run.sh, and this is going to start the controller. So while that's starting, one important thing is to let it start. So we've still got some ordering issues. So if you try and stack while the controller's got one module loaded, it's not going to like it very much. I'm going to jump in with another window here. Yeah, what was the address? 192.168.56.101. Thank you. Oh, so we're going to go back to the DevStack directory.
Maybe you can clone the compute
Oh, yeah.
in the meantime.
Yeah, good point. We'll clone. Actually, I'm just going to re-import another image. So we're going to import the compute node. So just go back to import.
So while testing, what we found is if you have more than 2 nodes, like compute and control, you have 3 or 4 compute nodes, please bump the VMs to more than 4 gig on the controller node, because the DevStack controller is really greedy if you have more than 3 compute nodes. Right? So increase the VM size, the memory to 6 GB.
And I didn't bump the memory.
2 is fine.
Yeah.
They're good.
Yeah.
I'm watching you, buddy.
So I'm just going to leave everything default. When you start it, it should say, oh, we didn't get the network error this time, so that's good. Just make sure we didn't get an overlapping IP. Just going to take a look at what the IP is, make sure, and we've got the same address. Perfect. That's going to be overlapping. We just have to, I'm just refreshing the IPs to force a new address on here, and hopefully VirtualBox is smart enough to do that. And it's not.
Wave down.
Yeah,
Sort of.
thank you.
This one is much better. Seems like it's trying something. Oh, don't use the NAT, man. Just use the. Don't use NAT. Just use host one.
Well, it needs connectivity to the controller, though.
No, host one is fine. Host one will work.
Does it give, should I do that or the NAT network?
No, have a host only, multiple host only, right?
Mm-hmm.
So then you can use host only as the only connectivity. That will work.
Okay.
You have multiple adapters.
You're saying here? NAT?
Here the view does not. You go to adapter 2.
Here? I'm sorry, so host only here.
No, no. How adapter 2 can you go to adapter 2? Second one. It's already this one, right? So we can make first one as VBox name 0 if we have 1. I know I don't have.
There's only one. Man, why is it not taking that? So it should not be giving out a second address. Let me try powering off again.
No, it doesn't.
Have you seen this? Or it's hanging on it? I've never seen it. Let me just try it. The joys of live demos. Sorry, guys. Yeah, you know, that's a good point. Let me clone it. Thank you. Thank you, thank you. Because it should know. It should be.
Might end up getting the same MAC address.
Right.
But we need to initialize it.
Oh, you're saying change the MAC address on the second? Okay, cool. Oh yeah, I could just clone this and it'll force it to do a new one. Where's my clone? Okay, well that's cloning. Let's go back to the other. So let's go ahead and stack. So with the controller, once we get to this group meter stuff, that's always, so those are the group tables for QoS. It's a good indicator it started. You can do a SS. Actually, you don't even have to grab it, just SS OVSDB. That's going to show the 3 bundles running. So we've got a northbound API, we've got a Neutron plugin, and then we've got the OVSDB implementation that has library and plugin.
For those who came to the previous session, right, this is the difference. We have the OVSDB.Neutron plugin as well here, right? While base edition has only the OVSDB and OVSDB northbound. So on the Bert edition, we have also the Neutron bundle.
So one thing before we stack, I just want to point out, so where it says offline true, that means don't pull dependencies from the internet. So that's a handy one, especially when internet's not so good. So let's stack it. So this is going down, what this is doing is configuring all the different services, Keystone, Glance, Nova. Take a look at this. Now, post-clone, I'm going to start this, and hopefully it did change the MAC address. Thank you, sir. Sorry, say again? Mm-hmm.
Stop the view. Stop the view.
Oh, yeah. Yeah, I mean, we can hard code it too. Just
Don't.
cut it off. Mm-hmm. Right. Thank you. So I swore it did that automatically. Sorry about that. Been using VM Fusion too much. Okay, well that's, no, I'll wait on it. I'm just gonna hard code, see what it does. Wow, it doesn't reset the NIC during it. Yeah, I'll give that one more shot. Actually, I'm getting ready to boot it in VM Fusion, so we just don't have to deal with that. Oh yeah, that's right. That's bad. Never mind. Right.
Actually, it depends on the NAT. If you don't use NAT, if you use a host only, it works perfectly fine. If you use a NAT, that's where
Oh.
it tries to optimize. That sucks. If you use host only, it will work.
Host only? Oh.
Host only works.
Oh, my bad. Let me do that.
I have two host only always, and then
Well, I thought that was how it was set on the clone. My bad.
I already created host only before doing this one. Right?
Okay.
Virtual box preference.
Oh, yeah,
Before doing any of this.
yeah. Right.
So, create. Host only. No.
Oh, sorry.
Create remote. And you need to configure it. Lazy
Well,
Yeah, you need to type. You type in.
I have to type it all in.
Stupid thing.
Oh,
Yeah, here.
God. What's the server address?
That's the one.
What's that?
That's the one.
The one?
Yeah.
Okay.
And give the low bound 100.
Actually, let's do 103.
Now we have to stop everything.
Yeah, it stopped. Except it was the 10 address that was the problem.
No one needs to stop the
Actually, I just need to change.
Stop the
I didn't do that on the. Just my little book over here. We did the wrong one. I mean, we got to do the other. Change the DHCP on the other. God damn it! Sorry. No, sorry. That didn't work.
That's fine. That's fine.
But it keeps hanging on to that.
No.
Yeah, got it.
Yeah, change to
Now what?
host only. You don't even have it all.
Adapter 1?
Yeah.
Okay.
Yeah, right.
Is that going to be able to reach the other?
VBox 1. Make it VBox 1. Yeah.
Okay.
And refresh the Mac.
Mm-hmm.
Then you have to change even the controller.
All right. I see what
That's
you're
the problem.
doing. Okay, sorry. Power this down really quick.
Yeah, stop it. Before you do that.
Do you already have yours up? Well, no, it's probably off.
I can bring it up if you want.
Might as well, just in case. Zero. Okay, we've got connectivity. Sorry. Let's get back in here. Hey, Madhu, we're going here, buddy, if you want. Come on. Okay. Sorry about that. So I'm going to, now that we've got both hosts up, we've got a 102 and a 103. I just need to change the host names to match and Etsy hosts. Reboot this, get the host name take effect. One more place. Name. Yes, that's right. Yes, sir.
Can you just check the config? It looks like it's V7.
Oh, yeah. Oh, sorry, I was just rebooting it. I do have a bad IP in it. Ah, damn it. Okay. Okay, now I'm just gonna go back and edit the local conf again really quick, and we'll be going. Just like local conf. Host name's good. Start the controller. Um, Actually, get that. So I'm doing the compute node now, so we're going to copy over the localconf.compute. So I'm going to overwrite the old one. Edit the local conf for compute. Hostname ODL2, that's good. We just need to add in the service host of the controller, which, oops. That's wrong. Hey, Madhu, the proxy address of the VNC, is that the controller?
Yeah.
Okay, that's what I thought. Oh, it's local?
Whichever is the local controller.
Running? Okay, so the controller's up and running. I'm going to go ahead and stack. Oh, it is? Yeah, bring it over here. Yeah. Please, sir. We should have had one running. Okay. Oh, sorry. So here's the running product that's stacking on mine right now also. So
So guys, I mean, just to be clear, right, the dev stack is not an easy thing to stack, right? Just to be clear, it needs a lot of groundwork to make sure it's working, right? So
yeah, and so in fairness, we don't do dev stack. We don't maintain it. That's what OpenStack uses for development,
Go on.
whatever.
there you go.
So this is the control. Is this, are you on a compute node or?
This is the controller node.
Okay, so on the controller node, there's a set of flows that are provided. We use 3 tables. So table 0 is a classifier. So all traffic that comes into table 0, you mind highlighting it for me?
Yeah. Just one second, guys.
That's probably too small.
I'm making sure this is
Oh yeah.
this is okay to view. Is it okay?
Oh, it's.
It's all right.
Anyway, so there's a set of flows for table 0, table 10, and table 20. Table 0 is a classifier. All traffic comes into it. Table 10 is going to be for tunnel traffic. So everything that has a tunnel ID on it is going to get sent to table 10. So it's kind of nice to break things up. And another benefit of multi-table is for debugging. So if you just have this one giant flow table, it's kind of brutal to find one little bug in a table, in a giant dump of hundreds or thousands of rules. And then table 20 is going to be for local VM traffic. So anything that's coming from a VM or basically doesn't have a tunnel ID on it is going to get punted to there. Do you have nodes?
Yeah. So thing is, as you can see here, right, in an OpenFlow 1.0 kind of implementation, you are seeing either in the Open vSwitch or other controllers, you would have seen 2 bridges. Those who are aware of the BR int and BR tunnel, because of non-multi-tenant support for 1.0. Since we do 1.3, you see only BR int here. There's no more BR tunnel. There's only one bridge that we managed to take care of the VXLAN traffic. And you can see here that the VXLAN interface has been added here. It's all dynamically done based on the VM availability on a given node. Say a given compute node comes up and the user has spawned a VM on a given compute node. Then based on the logic, we'll establish the VXLAN tunnel between the compute nodes based on the availability of the VM. So basically a VM locality. And the important things to follow here is the key equal to flow, right? So this is the support in 1.3. It's not in 1.0. That's why 1.3 is preferred one for us, even though 1.3 today we use MDSAL for the deployment. It is not the default one because the code came in late. We couldn't do a lot of good testing there, so it is not the default one. But if you want to do a scale, really good scale for tunnels, I would say try 1.3. It works in most of the time. We tried it. Yeah, good point. See, so the local IP is the configuration, right? Today, if you look at the Open vSwitch plugin, right? The local IP configuration is done in one of the Open vSwitch plugins configuration directory. We need something similar because if you don't have a local IP configuration, the controller will not know what is the tunnel endpoint. So for tunnel endpoint IP address, we don't want to use the management endpoint, right? Because you,
Remote IP reachable, let's say you have 2 IP addresses, right? So you pick the one which is available. The source IP should not matter.
okay, source IP should not matter, but the source IP, the reason that you see source IP here is because OpenFlow 1.3 doesn't support natively, OXM doesn't support local IP equal to flow. Doesn't support it. It's an NXM extension, right? If you look at if you open the 1.3 spec, you'll know that the local IP must be configured. If you want to use pure OXM, you have to do that. If not, it's not going to work. Right? But end of the day, let me be clear. End of the local IP is just it doesn't matter. It really doesn't matter, right? But in order to find out the remote IP, right? you have to know the endpoint IP address. How do you know the IP address is using the local IP configuration, right? So because the controller, the OpenDaylight controller, when it establishes the VXLAN tunnel, it has to know which is the endpoint for the given compute node, right? That endpoint compute node, we don't want to assume the management IP is the data path IP as well, because of course we don't want to, right? So even though we know the IP address of the compute node when it connects via the Open vSwitch OVSDB connection, we will not use that IP address because that's a management network which we will not touch. So we will let the customer give the tunnel endpoint. That's if you look at even today's Open vSwitch plugin in the OpenStack, you have a local IP configuration on the configuration file. You already have it. But one beauty of this solution is our solution here is agentless. There's no agent running there. There's no more OVS agent running there, right? Since we use OVSDB, which is natively implemented in Open vSwitch, we use just that. So that's one less administrative thing for the DevOps, right? But the local IP must be configured still, right? So what we have done is we made use of OVSDB itself, right? So if you look at OVSDB, so I'm dumping the OVSDB command here. So as you can see here, this is the only thing that we ask the DevOps when they boot up a compute node, right? Using Puppet Chef or whatever what we may have. We ask them to configure local IP as part of the OpenSwitch table's other config, as you can see here, right? So by doing that, doing the node bring up, which is anyways you have to do some configurations doing the node bring up, right? The only additional thing we ask the DevOps to do is do this in your Puppet Chef, and that is it. Once you do that, since OVSDB connects to the controller and gets the information, when it does that, it reads this particular information and knows what is the tunnel endpoint and start using it. And as I said, this local IP here is used as a remote IP for the VXLAN, right? And you rightly pointed out that this is not, this is not needed, actually. Yes, I agree. But it's not wrong to have it because we don't want to, right? So having this local IP here really doesn't make any harm, okay? Yeah, so does that answer the question? Yeah. So if you look at the solution here, it's agentless, no agent running there. It's pure, you as a DevOps install the Open vSwitch on the node. During the bring up, just configure the local IP, and that's it. Now then we based on the VM location, we establish the tunnels appropriately, and key equal to flow, meaning that only one tunnel is needed. Don't need multiple tunnels per tenant. And this information is populated by the OpenFlow command. So if you look at the OVS OF control commands, this is all populated by the controller based on the knowledge. The Neutron gives information about the MACs. We learn the MAC information. We program the local MACs for forwarding, and you can see here. This is the critical part here, right? This in table 0, that means packet is coming in from one of the VM tenants, right? DL source, and we set the set field. So the action equal to set field. This is natively supported in OpenFlow 1.3. Okay, so we use this set field operation to set the tunnel ID as the tenant ID, and this is used for the key equal to flow in the OVSDB tunnel itself, right? Exactly, yeah. So this is the high-level stuff of how it is done in a running controller. If you want to showcase, you can showcase your stuff.
Yeah, it's. Well, here. Do you have the? I've got the.
Does it claim that you don't need multi-class to discover the remote endpoint?
Yeah, okay. The VXLAN multicast is not implemented yet. This is VXLAN unicast. And you're right. Since the local IP is a configuration that customer can do, because in OpenStack typically, right, it's completely proactive. Because OpenStack implementation knows almost everything that you really want, right? From VM MAC address to VM's IP address to everything you really want. That's the case, then why do you need, it's a complete proactive solution. So even VXLAN, we established a unicast channel because we don't need a multicast thing.
Yeah, I think that's my question. So you're kind of leveraging the OpenStack information about the entire
Correct.
network to make sure.
To me, the OpenStack is one of the great examples for using OVSDB, OpenFlow, and then proactive mode, because there cannot be a better use case than this. That's hands down.
Yeah, I mean, if network virtualization is the killer app, I think it's pretty clear OpenStack is going to be that application of it. One thing, did you note that, so we do flood today, so we're not intercepting ARP. That's definitely on what we're going to focus on over the next 6 months before the next release.
There you go. I'm highlighting that.
Yeah, so we do flood to a VTEP in that instance. There's a couple different ways. One thing we're thinking about, theoretically we can use OVSDB since there is a MAC address awareness there. Neutron has awareness of location. You may not have to even punt that ARP. So since we have that visibility into the vSwitch, we could theoretically, between Neutron and everything else, isolate it down to a hypervisor and just spin it up there. And again, though, somebody has to answer ARP. So that's kind of always going to be the problem, whether that's going to be a local, something in vSwitchD that's going to answer ARP, or whether that's punting it all the way to the controller. That's what we're going to work on over the next 6 months, if anybody's interested in that.
Yeah, and just for the sake of it, right, I'm totally a CLI guy, so I don't use the Horizon UI to create all the cool instances, because essentially I have so much things in this, it sucks. So if you want to create a VM, just do a Nova boot. I'm doing a Nova boot. It's going to create VMs, and you can start seeing the, based on the location and everything, you're going to see the things start working. So essentially, that is it.
What about having between two different subnets? Would it still go to the network node, right? Or does it directly go via the with the tenants? Do you set up the tenants for in between subnets?
Yeah, we don't have any east-west on the edge yet. And again, that's going to come down to ARP. So somebody's got to answer ARP to have a DMAC to send traffic to. Whether that lives in the controller, I think a lot of us would prefer not to necessarily. I mean, it'd be nice to be able to have a fully proactive implementation. But over the next 6 months, we're definitely going to experiment with that, see what the scale looks like. There's some patches that have gone in vSwitchD lately that show some form of proxy, so that might be interesting. If we had a native implementation of somebody answering ARP on the data path, that solves some fear of punting any traffic, but it also adds some complexity of tracking state of all the ARP in the network and that sort of thing, if it is going to answer.
So to be clear, right, this implementation that, as you said, we ran to the finish before the Hydrogen release. So we kind of took care of the L2 use case end-to-end using OpenFlow 1.3 and OVSDB. Even the ARP handling today is not done on the controller. We flood the ARP, right, and learn it on the edges, right? So essentially, the controller is acting purely proactive, right? The Neutron APIs that we get from the north and the OVSDB APIs coming from the south are our triggering points. We get control plane, install the stuffs, and be out of it. We are not even forking the DHCP. We are not even getting the ARP. All are flooded and goes to the appropriate services, and they get served. And after that, things start working fine, right? So obviously, we know. Obviously, this is not a scalable solution. We all know that, right? So that's what we are going to be heading for for Helium release. So Helium release, you'll start seeing more features like supporting better ARP, L3, DHCP, so on and so forth. And just quickly, I thought this slide will be useful for you guys. Is it okay?
Oh, please.
So you guys thinking about whether we use multicast, native multicast, or wonderful point, or proactive ARP proximity, and then how are you going to do that? Blueprints or discussion? What approach to take?
Yeah, so we're actually going to have a sidebar here because a lot of there's some great guys in the community that are helping with this. Again, this started as
and we definitely need your help, right?
Yeah,
So since
that's
you're talking
long story
from
short, is we're going to be talking about that. So if you want to get engaged, irc.freenode.net.
Ashwin is there, and I know. So, and
Yeah.
not just from the so the community member is like we have Kyle from Neutron APIs, right? And you have the customers right here. So all we need help from you guys to drive the requirements to us so that we know exactly what you are looking for, right? So in fact, Yuri is here. he was asking about what is scale support and whatnot. We haven't even thought about it for Hydrogen yet, right?
Yeah.
So we made the functionality look approachable. So you guys try it out and give us feedback. And I personally hope that Helium will be the much better release for real deployments, maybe.
Yeah.
Not Hydrogen is for your lab. Give us feedback and we'll take it up. And we're going to give it back to Ashwin to fix the code.
Yeah, I mean, kind of a funny story on it. Like, literally, there was no kidding, a sprint to the last. So I think we code freezed on Monday. Madhu and I were basically taking turns, all-nighters. I think that morning, code freeze was at noon. I remember being on a hangout with you, and I pretty much just fell asleep on my keyboard because it was his turn to get a couple Z's. And so we had a problem at the end, and it was basically a flow mod was getting evicted. And so, fortunately, Madhu caught the bug, which was we were sending without a strict. So there's probably a flow mod in here that's getting evicted if you pulled strict off.
So doing development, we found a lot of issues with DevStack, bringing it up and whatnot, which we saw here
As
also,
you can
right?
see, again,
Right?
yeah, sorry about that.
So what we did is, since we are from Red Hat, of course, we had to make sure it works in RDO. And Srini is here, I guess. We got it working as well. We have it working with RDO, Red Hat solution. It's all working end-to-end. So we'll be refining it more as we make progress. And this slide, maybe you can talk about it, right? This is the end-to-end picture of what we have achieved so far and where we have to go. As you can see here, right, the Neutron application running on top is really an application. It's really a pluggable one. It's not even embedded into controller or anywhere. It's a running application there. It talks to the MDSAL for the OpenFlow 1.3 plugin, and 1.0 is going to be ADSAL 1. And you can see the services that we use today are configuration service, inventory service, connection, and flow programmer. It's not even using ARP or any of the other things that you will expect us to use. Okay? So we kind of make use of OpenFlow kind of effectively, where we flood where we want to flood, right? And we never punt. That's the goal. And we kind of punt LLDP alone for nice UI to show that we have a tunnel established between the endpoints. But pretty much it's not for operational things. It's just for the UI kind of thing, right? But other than that, it's pure proactive today. And we have this Deluxe project. Dave and Andre is working on that. They have done some really wonderful work on the UI side where they take information from the Neutron and they take information from the OVSDB and plug them together. So from administrative standpoint, you can drill down, you can go to the Neutron network ID, go to the port ID. From there, you can directly go to the OVSDB port, and you get the end-to-end picture. It's really beautiful, right? And I don't know if Andre is here or not, but I don't think he's here. He has a session tomorrow, I guess. I hope he's going to talk about that. If yes, then it'll be fun to watch. Yeah. So we tried to attack it from various angles. We kind of work from a network, bringing together, and we recognize management is one of the key things to have anything deployed in any of the networks. So Deluxe is helping us in that angle.
Yeah, I mean, I think it's probably worth pointing out again that, we need community because, I think some of you guys probably heard over the past year, right? We've heard application's where the value is and all this. I don't think that meant a whole bunch to us until we really started digging into these kind of critical applications because so, I mean, what we have here is basically this integration with a controller that, companies are built around. This is, what Madhu and I and, Kyle on the OpenStack side, and then, a handful like Ashwin's in the audience right now, part-timing it, me recently full-timing, but if we can build these, these whole kind of solutions. It's kind of crazy, so.
And I would say it's not too complicated as well. I mean, surprisingly, right? I mean,
yeah,
the entire OSDB Neutron work took us what, 2 months?
Yeah.
In 2 months, we're able to get from nothing on OSDB Neutron to kind of completely working 1.3 implementation with end-to-end kind of working, right? To me, it's like unreal because we just two full-timers trying to do things, and it's not even complicated, right? Maybe new features could be complicated, scale could be a complicated one, but functionality-wise, I still don't understand why it should be a proprietary solution. It's not anymore, right? It has to be open, right? Yeah. And we need participation from all of you guys, and it's simple, It's not complicated. Yeah.
Well, yeah, I mean, I think it's a good point. The value is so much above. I mean, this is just plumbing. So I'm not sure there's a lot of, necessarily a lot of monetizable money in just doing network, doing flow mods or doing, you know, routing or whatever you're doing, you know, I mean, that kind of, we need to get beyond the point to where that's, you know, differentiations and wire protocols. I think it's kind of.
So services is going to be there, right? So once we implement all this, the OVSDB as a, the reason we are in OVSDB is because we recognize that that's going to be the one that's going to help us achieve all this. So those are building blocks. Right? We kind of put a solid building block. So we're writing application on top. We'll add feature by feature. The requirement from folks like you guys, right, from eBay and who are actually trying it out on the network, we want feedback from you, right? We want what are you looking for? What are the scale requirements? What are the services that you are looking for to hook up, right? If you can give all these requirements, we as a community can again pull together and then get things done. Because as I said, it's not difficult at all. Once we get into this, we recognize it's not difficult.
Well, and so, I mean, the difficult part is what you saw, and it's just, there's a lot of moving parts. Just to develop an OpenStack, it's, unless you're pulling single packages to put all this together, it's kind of crazy. I mean, we've literally probably spent almost as much time, like, getting the components of OpenStack to kind of get a good dev environment for people, as opposed to actually writing code into Daylight. So, you know, especially, you know, today is a good example. This is in 6 months, we're going to be laser focused on, you know, hitting the enter button and you get a demo for you guys, not something pre-canned, which was the goal here, was to show that you can kind of go from nothing to a working stack, but obviously it's got, you know, what, 45 minutes of setup and fumbling around, which is obnoxious, so apologies for that, but that is the reality of developing in this right now.
So we have slides. I mean, if you guys want to try it out and fail, I would say please fail so that you will know what difficulties that we are facing here, right? It's not a failed demo to me because it's the natural thing for your stack, right?
Yeah, that's true.
So we will also record videos when we both are like fanatics into recording YouTube videos and then sharing with the community. We'll still do that with the 1.3 stuff. And, you know, get back to us. We are in the IS chat all the time, you know.
Yeah, definitely on Freenode.
Yeah.
Is there any more these are awesome questions. I mean, literally, like, we wish we had more conversations with the community, more interest in what does the network look like, because sometimes it ends up being at 4 a.m. we make a decision because we need to get it implemented, and it's definitely not the best approach. So, you know, more input from you guys on what you think the future of the network should be. And even if you're not, you know, a developer or coder, we can fix that, you know. It takes some passion.
And perseverance and patience.
Yeah, yeah. And not much of a life.
Well, all right. That's it.
So do you want to, does anybody want to see more demo type? I mean, we can do the mini-net, we can do any outstanding questions, seriously.
So, how does this compare with the base OVS could you sort of,
Yeah.
Great question.
what advantages this brings?
First of all, the base OVS plugin is an OVS agent running on the compute nodes, right? You know that, right? And the OVS plugin uses all the proprietary NXM extensions, right? You'll see. I mean, once you start, is it base OVS or is it?
No, are you talking about the base Daylight or base like ML2?
OpenStack.
Oh, yeah, definitely.
Using it, you use the OpenStack OVS.
Sure. So
Yeah.
I mean, it's clear. Somebody, you know, let me say this first. Like, obviously, what Martin Casado and everybody did is amazing. They've got, you know, the other thing that I will say that's really impressive is they're pushing the spec upstream. So, you know, it kind of surprised me. It doesn't surprise me, but I think it's important to note that they're pushing the OpenFlow spec and the implementation, because we wouldn't be able to do this with pure OpenFlow. We wouldn't be able to do tunnel networking without it. But if you look at the ML2, it's using a lot of proprietary extensions, resubmits, which, you know, the
Tunnel source IP equal to flow.
yeah, and I will say this, it would be nice to be able to set with pure OpenFlow, to be able to set a tunnel IPv4 destination. You know, I think there's some interesting things between, you know, where the management protocol ends and where the OpenFlow or any other control protocol begins. So being able to set a tunnel IPv4 destination, I don't even be able to set a tunnel NCAP. I mean, what is an NCAP? It's some bits that, you know, ride along behind. So being able to set some of that stuff in the control protocol as opposed, you know, I think they should all be on the table. And, you know, if we have choice, then, you as a developer, we can decide and say, oh, this is the easiest to implement, or this is the lightest weight, or this is the best performance.
So one thing I have to say is OpenFlow 1.3, this is it, right? It's really one up to 1.0, right? A lot of good things are there. And especially the tunnel thing, I'm pretty surprised because it has a lot of set fields. Tunnel is part of one of them. It's kind of good forethought where now we are going to, everyone is going to need that for a virtualization solution, right? It's already there. And I was very surprised to have that, see it in part of OXM. And thanks to all the nice set of folks who really upstreamed it into the OpenDaylight switch, into OpenFlow 1.3, right? Dan is also here.
We got the man in the front row.
So
thank you, Dan.
thanks for getting it in. So yeah, of course, since we are too deep into it right now, we'll start proposing more things to 1.4 and beyond to have things like set the tunnel destination IP from the flow, have the VXLAN or the tunnel encap again from the flow. It'd be cool to have more flexibility so that you can keep scaling up. But 1.3 is very impressive. I mean, from 1.0 to 1.3, we saw a marked improvement right there. So.
Well, no, I think another thing that would be, because we work for Red Hat, so we're a software company. So we're not saying overlay is the end game. This is just what we can code today, and we can say to any of you guys in the audience, yeah, you don't have to rip out your whole network. I came from operating hardware network for the past 3 years with OpenFlow and production, and it's the hardware is still evolving. We've had some great conversations this week, so I think programmatic hardware is obviously getting a whole lot closer than it used to be. So, we're pretty agnostic to it. We do, I think we see a lot of value in understanding what is going on in this underlay, especially as we start getting into how do we drive flows over hardware networks in a service provider environment. Middle box eradication, or sorry if you work for a middle box company, but that's where the CapEx savings is going to be. If we can pick flows off and drive them through x86, I think there's a lot of interesting things that happen there. Like what the VTN guys are doing, it's really cool. They're doing flow aggregation. They're really aggressive in the actual hardware network, which is pretty cool. But this is something that you can pretty rapidly prototype, and you don't need to rip out the network. So there's a lot of attractiveness to that.
Hopefully for Helium, I think you should integrate with VTN, right?
Yeah.
VTN and OVSDB should be a big killer combo.
Yeah.
It'll be a killer combo.
Yeah. So that's the kind of stuff we're doing. Like, if you have a good idea, then you bring it, and you don't even have to have a good idea. Come talk to, we have conversations randomly in the middle of the night and say, hey, let's do that, and we go do it. So pretty bizarre and crazy reality world, but it's pretty awesome.
Yeah, rough consensus, right? Yeah, really, that works. We have seen it working already in many times, right? From OpenDaylight initiation to OVSDB Neutron. None of them were like really well thought of and everything. We just learning as we code, and we code as we learn. Now it's really vice versa, and it works out really well. Yeah? I have no complaints in that approach.
Yeah. And we've really, I think another interesting thing, we're starting to see friends from the networking community, knuckleheads like me, come in and actually get involved and roll some code. That's pretty exciting because they definitely do need to evolve. Computing evolved, networking, people are just going to have to evolve, particularly in the data center, obviously. So if you haven't gotten into much of this yet, just hypervisor networking. Without it, you can't, emulate networks and do any kind of development, test dev, anything like that. So it's a great place to start. Is there any more questions? Yes, sir. Yeah, that's a great question. Yeah, so that's the.
What was the question?
So we're only using one bridge with 1.3 on the data path as opposed to 2. So traditionally there was a BR tunnel and then there was a BR int. Int stands for internal.
Integration.
Oh, integrate. I always say internal. He always
It's all
fixes
right.
me. I know.
It's bridge integration bridge, yeah.
Yeah. And so BR integration was mainly used for flooding and things like that. So you've got to mark it with a VLAN and keep tenants isolated. So in our 1.0 implementation, we do flood on that internal, and we mark it with a VLAN to keep separation. Here, with flow mods, we're controlling every flow. So we don't even have to worry about tags, anything. The only tags we worry about is just the encapsulation tag. So it's kind of that granularity. And, when you hear the VLAN needs to die, well, that's kind of part of the VLAN dying is, well, two ports don't talk to each other regardless of, what, you don't need a tag there to separate them because they're not talking to each other if there's not a flow mod that's set up there. Oh.
Prior to 1.3, we had separate data tunnel. It was away now, the VXLAN tunnel shows up that virtual ports.
Yeah, right, exactly. And
Sorry.
one thing crazy about, I forgot to mention this point about the coding and learning, right? One is an interesting thing that one student that came from Norway is a PhD guy, right? He wanted to try out something new on the OpenStack. It was 2 weeks back, really, right? So what they really wanted was they want per bridge for every tenant. A tenant will have a bridge, right? I mean, sure, try it out, right? So came to the code. Is it possible? Yeah, of course it's possible. It's nothing possible. So they just coded it in 2 days, really, right? Use the same OVSDB Neutron code. Just start creating bridges for every tenant and having tunnels inside the bridge. So what's happening here is now they have 2 tenant isolation per bridge. It's like, if you look at today's code, right? I mean, we use the tunnel ID, VLAN ID to isolate them internal, and then from there we hope that everything is going to work properly, right? These guys are the research person. They have done it already. They create bridges per tenant, and the idea is to have a secure tunnel end-to-end between the nodes, so they can claim full security, right? And NSAs cannot come and tap into a bridge because this bridge is locked for this tenant, and that bridge is like completely sealed for them, right? So no more, from management standpoint, you can be guaranteed, right? Since the BR integration bridge, everyone is like in the same bridge, it's hard to know who's where. With this idea, you can just be guaranteed, it's sealed. NSS cannot tap into it, right? I kind of like the idea, and folks are doing it. Sorry? Yeah, right. So they do the end-to-end security, and then it's boom, it's done, right? What I'm saying is, it's all possible. I mean, folks just who are interested, they come and do it in a couple of 2-3 days, really, it's done. Now he's looking at how to do the secure tunneling inside the OS and so on and so forth. So it's, sorry? Yeah? Yeah, so open research, ODL doesn't distribute OVS, right? OpenFlow 1.3, yes. Yeah.
That, and bring it in. Yeah, so it's in the distribution. If you go, so the base distribution has both 1.0 and 1.3. It also has OVSDB. It doesn't have the Neutron bundle. So if you pull the virtualization,
Actually, Shini is here. So you tried RHEL 6.5, right? That has 1.3 already in support. Yeah. So she tried RDO in RHEL 6.5, and they're able to get the 1.3
OVS distribution. I'm sorry. Yeah, so that's the beauty. So the great thing, we just did this the other, it's 2.0 out of the box, 2.0 plus, and actually it's really easy. It's like 2 lines on Fedora and it was there, so it was pretty nice.
Fedora typically gets it quicker. Even RHEL has it now. Yeah, 6.5, we have 1.3 working with VXLAN. Yeah. The VM that we gave, it has all this information, and the slide deck, maybe if you upload somewhere, you can take it up.
Yeah, and we'll have instructions and a video up with the images. Obviously, the images on some hypervisors are going to be trickier than others, but we'll have documentation and all that through. We really haven't, I think we got rewarded with grinding pretty hard with Go Write docs for 48 hours, so we're still working on that. But again, probably the IRC channel is the easiest way to get set up. Yes, sir. So that's probably that and ARP are our 2 number 1 priorities for the next couple of months. So we can do access lists quite easily with flow mods.
We kind of do just for one case today, the Mac kind of X list, right?
Yeah, that's true.
But yeah, so that we have a Trello page. If you're interested, we have a Trello page where we list all the features that we are working on for the Helium release. If you propose anything, you are the code, right? So,
Yeah.
so
Yeah.
please be ready for that. And no, we encourage coding really because that's the only way people learn really. And we have seen some really quick learners out there.
I mean, as most of you know, this isn't like a product demo or anything like that. This is developer demo. This is all raw. Yeah, bringing those kind of things are, that's what we're on. That's I'm not even sure how we're going to prioritize yet. And really, it's going to be up to the community to help us prioritize. It's not like, customers aren't coming in and saying, hey, you have to do this. We're sitting around talking, asking everybody, and say, okay, well, let's do this now. Or we branch off. We have enough people that day, and we build it. So it's pretty cool. Yeah. We'll get your card. Cool. Any other thoughts, questions? Cool. Well, thank you guys so much. Apologies for the delay at the beginning, so thank you all.